Hi, everyone. I just want to say thank you very much for joining us today. As we know, this is our first day of virtual open week, where we're having a lot of sessions lined up for you in terms of getting to know more about EIT and what we actually do. So, in fact, at the end of this presentation, I will share the link with you so you can see what's it's lined up for this week. So you can just continue and do some registration. And then, just before we start with today's session, if you can just quickly ensure that you disable all the sounds and the notifications. I just displayed some instructions there. Okay, so welcome to today's session. As I've mentioned, it's our virtual Open Week 2025, and today we'll be hearing from our lecturers touching base on civil and structural engineering at EIT. Today I'm joined by Dr. Anna, Dr. Igor, Dr. Kumar, and Dr. Shasha. These are our course coordinators here at EIT and also lecturers. So just before I hand all things over to our team, just some common questions in terms of the recording, the slides, and the certificates. So we will be sharing the copy and the slides of the session. Just look at your emails between Monday the 14th and the 15th of April, and just also ensure that you monitor your junk folder. At the end of this session, I'll be sharing the QR code or a link that you need to follow in order to be able to claim your certificate of attendance. So you need to attend this session all the way to the end. So I will share or provide you with the link or QR code in order to claim your certificate of attendance. Just know that yeah, we're planning to send it out between the 14th and the 15th of April. And then on that note, I would like to hand things over to Dr. Anna for a quick introduction. Dr. Anna.
Thank you very much, Barry, and welcome everyone. I'm Dr. Anna Evangelista. I'm a civil engineer. I'm also the course coordinator at EIT. I joined EIT a long time ago, more or less 5 years ago, and currently I'm teaching bachelor's degree units, master units, and also supervising doctorate students.
Thanks. And then I'll now hand things over to, I think,
Igor.
Dr. Igor.
Igor
How are
Shufrin,
you?
this is me.
So,
I'm good.
sorry, I was just checking
So,
you on the site. Yeah, thanks.
all right, can you hear me, right?
Yes.
Yes. I'm Dr. Igor Shufrin, Senior Lecturer in Civil Engineering. I'm also a course coordinator with it at EIT. Been working here longer than 2 years with my previous experience with different universities around the world. I teach in areas of different types of structural analysis, earthquake engineering, dynamics, high-rise buildings, and high-rise buildings. My research expertise is within composite construction and computational mechanics. Over.
Thanks, Dr. Igor. And then I will now give it to Dr. Kumar.
Yeah, I'm Dr. Kumari Gamage. Actually, I recently joined with EIT and I have experience in different universities last 20 years. I specialized in structural engineering and my research interest is like sustainable materials, composite structures, structural assessment and retrofitting. Yeah, thank you.
And then last but not least, Dr. Shasha.
Hi. Hello, everyone. Thank you, Barry. I'm Dr. Shasha Wang. I'm a lecturer in civil engineering at EIT based in Melbourne campus. And so I'm also the course coordinator for Bachelor of Science, Civil and Structural Engineering. I'm also teaching some master unit, bachelor BCS unit, and the MCS unit, as well as supervising a couple of doctorate students. My research interest is mainly focused on high-performance cement-based materials, sustainable concrete, and so on. Yeah, that's basically all from me. Thank you.
Okay. And then, yes, looking at the agenda to it, that will be an overview, then course information, civil and structural engineering, showcase, remote and virtual lab summary, and then we'll have, if you have any questions, please just wait until the end of this session, and then our team will be able to answer your questions. You can take it away, Dr. Anna.
Thank you very much, Barry, once again. Yeah, today the main idea is to discuss different aspects of civil structural engineer. That's why later on we're gonna share with our participants some activities we normally offer to our students. We offer remote labs, virtual labs activities. And at the end, definitely we're gonna have a session, Q&A session. So you can contact us if you need any other information regarding our civil and structural engineering course. So to start with, I would like to give you an overview in terms of the alternatives, engineering pathways at EIT. So these diagrams show us the opportunities you have. Depends on your aims and goals. If you are working at the industry, so we'll value a lot work experience. That's why here you can see you can start your qualification. EIT offers advanced diplomas, and we also have some opportunities to our year 12 students. We can combine qualifications plus work experience. So this is the natural pathway. If you start joining us, let's say with the advanced diploma, then you can progress to our undergrad, or if you decided to join straight away the Bachelor of Science, we offer 3 years course, Civil Structural Engineering. And then if you'd like to progress with your qualifications, you can continue and go and to join the master course. We offer our master course, Civil Structural Engineering, or we have also the alternative to do the graduate diploma, graduate certificates. As you can see, that's a variety of course, postgrad course that you can enroll. At the end, we have our doctorate program, Doctor of Engineering. It's, EIT, we have students in different countries and also here in Australia. So that's why it depends on your aims and goals regarding your career, your professional career. You have so many options at EIT. So now it's over to Dr. Igor to talk more about the different areas under this big umbrella of civil engineering. Over to you, Dr. Igor.
Yes, I'm here. So the accreditation to go on. So civil structural engineering. Let's start. So what civil engineering is? So civil engineering is a broad discipline and one of the oldest professions in human history. It is dating back to construction of ancient roads, bridges, aqueducts, and even pyramids. It is dedicated to design, building, and maintaining the infrastructure and supports modern life, from the homes we live in, and the water we drink, and the roads we travel, and the cities we call home. Right. Civil engineering, as you see here, includes several sub-disciplines. So it's all these pictures which you see on this slide belongs to our area. So
Sorry,
we've
Dr.
got-
Igor.
Yeah.
You can take control on your side.
I think I've done this. No?
Okay.
I think I am in my opinion, I am in control.
Okay.
Thank you,
Okay.
Barry.
Perfect.
Yeah.
Perfect. Thanks.
Yeah. So the civil engineering includes transportations, engineering, structural, environmental, construction, of course, geotechnical, and also water resources. So let's just have a quick look at all of them. Geotechnical engineering focuses on the behavior of soil, rock, supporting foundation, tunnels, earthworks. So figuratively speaking, it is providing a ground to the construction project. So geotechnical engineers evaluate the stability, strength, and deformation characteristics of soil and rocks. So they design safe foundations for buildings, bridges, tunnels, any engineering structure. Their work will include soil testing and site investigation. They will design footings, piles, any type of shallow or deep foundations. They will evaluate the stability of the foundation, slope stability, and they will design earth retaining structures, all type of retaining walls from a couple of meters to a couple of 100 meters. They will also be addressing groundwater flow. Next, we have the water resources. So the water resource engineering manages the flow and quality of water in the rivers and dams and canals and stormwater systems. It's all these nice pictures which we see here. So the jobs of the water resource engineers, the jobs will include the evaluating of dams, designing of dams, and the building the dam breach models, flood propagation models, all different types of flood analysis, and they will also include they will also deal with the modeling of water resources. So this how the water collecting how the rivers collect water. It's quite wide area, but this list of my examples is definitely not exhaustive. We've got much more to do in this area. This area is quite broad. There's another sub-discipline here is the transportation engineering. So transportation engineering plans and designs efficient systems for roads, railways, airports, public transit, like bus station and so on. The transportation engineers work on highways, road networks, railway systems, which both passenger and freight systems, including track design, transit planning. That's a whole sub area of the transportation engineering, which is called the railway engineering. They also design airports, which also will constitute a whole sub area of this. Traffic engineering and ports and harbor is also a very wide area of discipline. Next one is the construction engineering and management. This area prepares actually students in this area to manage the design, construction, and operation of sustainable buildings and infrastructure systems. And this area employs the most of civil engineering graduates. So you can see how much busy they are when by removing this construction waste of the road. So it is obviously a joke. It's an important role of seeing construction sites, ensuring safety, ensuring the proper construction procedures.
Sorry to interrupt you, Dr. Igor. Can you please click on take control once more of your slides?
It's fine, I can list them. I'm listing them. I don't know what's the problem.
I think the slides are not synced to you. If you can please just take control once more.
Cannot take control anymore because I am in control.
All right.
I can't tell what else do you want me to click? I don't even have button take control available. Right? So we can go on and to where we stopped, structural engineering. Of course, structural engineering is the closest to my heart. It is to ensure that the structural engineering is ensuring that the stability and safety of building, bridges, skyscrapers, any other load-bearing structures. So load-bearing structure may be a new term for someone who, in our audience here, who is not a civil engineering student, but load-bearing means how much load a structure can carry, how much load we can put on it. And that's one of the important parts when we design and analyze structure. So what do structural engineers do? They design, analyze the residential and industrial buildings. They deal with retrofit of existing structures, which includes assessment of load-bearing capacity, includes the making decisions on how it can be repaired, and if it's possible at all, bring the structure to the current standards. It also includes designing of earthquake-resistant structures. So the structures that can withstand strong earthquake. The most amazing part in structural engineering is obviously skyscrapers and bridges. So these unique structures will stand after the structural engineer who designed it passes away. So they actually make difference by designing by designing such unique structures. Another exciting area of structural engineering is implementation of novel materials. So implementation of novel materials in construction. So this includes development of such materials, the testing, and some type of standardization, so everyone would be able to use them. Right. A couple of more sub-disciplines, maybe a little bit less. You can imagine they're not really there, but they are. So we're looking at architectural design engineering and environmental engineering. So architectural engineers are trained with rigorous technical knowledge and about building systems. It can also include urban design there. To become an architectural engineer, it's important to earn a bachelor degree before that in a related field, structural or civil engineering. Please remember that's an important difference. Architecture is a design degree. And you obtain such degree from an art school, a design school. While architectural engineering is a degree that bridges this gap between professions of architecture and structural engineering. So this is another one here on this list is environmental engineering. Well, we can read if you go online and you just ask Google or nowadays any other AI tools, which industry impacts the environment the most. And you will find that actually this industry is civil engineering. So civil engineering, so civil structures impacts environment the most. So I believe it is logical to have the environmental engineering which addresses which protects the environment in the same area, the same umbrella. So environmental engineering addresses water treatment, waste management, pollution control, and other sustainable practices. The importance of all these topics is commonly recognized worldwide nowadays. So, now I lost control. But that's probably because I'm done.
You need some help, Dr. Igor?
No, I'm done actually.
Okay. I believe the next one is it Dr. Shasha?
It is actually Dr. Kumari.
Okay. Are you able to take control, Dr. Kumari?
Yeah.
Okay, perfect. Thanks, Dr. Igor.
Thanks, Berry. Yeah. So we all are interested to know how we can perform in our profession after completing a civil engineering qualification. So let's see how we can do. So no, every nations contribute to infrastructure development, management, and monitoring. Even if a country faces economic hardships, war, or disasters, because this is a basic need of people, which is equally important as food and clothing. So civil engineers always have job opportunities anywhere, any part of the world. So structural engineering is a critical field of civil engineering. Most engineering disciplines cannot perform without contribution from structural engineers. So, who will analyze, design, and construct reservoirs, power distribution, supporting systems such as towers and cables for electrical engineers' contribution? That is structural engineer. So again, we'll see design and provide technical support to construct airports, runways, ports, harbors, and other supporting structures to perform aerospace engineers, aeronautical engineers, or marine engineers. So we need civil engineers, structural engineers. Like this, civil engineers play a significant role in succeeding all other engineering disciplines. So it is a very important field, especially directly related to the economy of the country. So another area you can practice for structural retrofitting is another demanding area. So you have seen we have faced many disasters in the recent past. So the structural damages is obvious. So no country can replace all structures with new structures. So civil engineers are involved in restoring such damaged infrastructures. Even in the disaster situation, so we need civil engineers to make them again into the real situation. So not only that, the current demand in the world is high with increased population and demand. You have seen heavy traffic in our roads and bridges. So we need to retrofit such systems to satisfy the current demand. So like this, there are varying opportunities for structural engineers to contribute to the sustainable development of their countries. So, like that, we are having any part of the country, it is in demand. Civil engineers have been doing research, not only doing analysis, design, or retrofitting structures. As a result, so we have uh, super luxury facilities to satisfy our needs in the current world. You have seen straw mud-based constructions in our past, but now you see skyscrapers, longer span bridges, dams, even 3D printed concrete. How all these comes? Because the scientists who work in the civil engineering field. So there are opportunities in such fields as well. So civil engineers have broad opportunities in the world. They have a good choice of selecting their future career even after completing the civil engineering degree, depending on their future circumstances. That means you have a flexibility when you are doing a civil engineering degree. As an example, civil engineers contribute to software development for the analysis, design, construction, and management of infrastructures. So, without civil engineers' contribution, no software engineer could develop such demanding programs. If you are interested in software engineering later, but your degree is in the civil engineering, still you can move into your favorite field with little training or maybe with little direction change. So, like that, there are huge opportunities in the world for civil engineers. So, apart from these potential popular job areas, there are unlimited opportunities for civil engineers. So, you can see in the common environment, we practice as a structural engineer, construction project manager, construction supervisor, site engineer, design engineer, transport engineer, or survey. That means measuring the lands, geotechnical related. All those are traditional job opportunities. So when we look at the surface of civil engineering, we only see these traditional and popular opportunities in our environment. So not only these, so in the current world, civil engineers practice without borders. That means there are many hidden opportunities for civil engineers. The basic civil engineering degree trains a person who can specialize in any direction, any broad, because it's a broad field. So you are getting the opportunity to start your career in your favorite field with diverse opportunities. If you look at the current world, so some civil engineers involved in digital fabrications, sustainable development approaches like maybe management or maybe developing materials and many tasks they are doing, and simulations, automations, computer related many activities. Even the top managers, most of some industry, we can see civil engineers. So these are some examples. So you are getting the opportunity to start like this in your favorite field. Not only this, nowadays the civil engineers develop deployable structures for even for space explorations. So that is exciting actually opportunities for civil engineers. Let's see how uh, can you approach this broad field with EIT. So we offer accredited courses, professional certificate, Bachelor of Science degree programs, master's programs, even Doctor of Engineering programs. So you can initiate your approach from any level and you can reach the topmost level with EIT. So now I'll invite Dr. Shasha, so she will let you know our way of developing graduates. Dr. Shasha.
Yes, yes. Thank you, Kumari. I think let me take control. Okay. Yeah. Well. Hello everyone. Here, I firstly want to share with you how EIT actually provide practical experience to our civil engineering students. Of course, similar to the traditional way, we know that in the traditional civil engineering courses, okay, the students will need to go to the lab and get their hands dirty. So here we also do this for our students, especially for our on-campus students. Okay, for example, here you can see the image of a picture that we took from one of our workshop conducted at our Perth campus, where the students get the chance to work with concrete. So, for example, we also have a short video here to illustrate some of the lab activities that the students did for concrete. So for example, we are actually mixing the concrete, and we also tested the fresh properties for concrete, such as the VB test to evaluate the time for the sump comb to fully subside into the container. So the time recorded, it is actually VB time. VB time is a parameter to indicate the workability of fresh concrete. Of course, there are other ways to test the fresh properties, such as slump test. Slump test is one of the most widely used methods to measure the workability of fresh concrete. And of course, there are some other methods, for example, flow table. Okay, so this is equipment for flow measuring flow. Yeah, so this is to measure flow of the concrete, which is also a parameter for workability. And in addition, of course, we also have the facilities to test the properties of hardened concrete. So this is a video casted by Dr. Igor and Dr. Anna. We test, we actually tested concrete. Yeah, so this is actually the load history of the testing. So we tested the 28-day strands of hardened concrete based on cylinders, the standard cylinders with a size of diameter of 100 mm and the height of 200 mm. So these are just some of the examples that we did in our lab. So basically, the students get the chance, especially the on-campus students, get the chance to go to the lab, which is actually, so as we saw here, this is actually part of our workshop unit or zero credit units. And we are also trying to incorporating those hands-on components into some of the units. So this is actually one way to get students get involved in practical activities. And of course, in addition to the traditional way, we also have virtual lab. Okay, for example, for in terms of the some testing, some experiments. So at EIT, we actually have the platform, which is a remote lab, where we do actually have different softwares installed on different remote labs, so the students can access remote lab to do all kinds of simulation, including and even some experimental study. Okay, for example, we do actually for civil engineering, virtual lab is actually one of the opportunities that we provide to our students, that the students can actually access this virtual lab to conduct some experiment virtually. So this is especially precious for our online students, so they get the chance to expose to experiments. Okay, so for example, as we can see, these are just two of the virtual labs that we have. The one on the left-hand side is actually the experimental work to determine the compressive strength of the concrete. Okay, so similar to what we saw just now in the video, the last session is actually about testing the strength of concrete. So in this virtual lab case, the student can start from selecting the mixed proportion, okay, for the concrete that you want to evaluate, and then what is the age that you want to evaluate? Like, is it 3 days, 7 day, or 28 day? And you have to. There is actually step-by-step guide, okay, where you can follow. Then you have then you get to know, okay, how you are going to actually conduct such kind of a compressive test in a laboratory environment, okay. And of course we are going to also record or report, okay, the results, okay. So for example, for typical compressive test, okay, the results that is reported by the machine, it is actually the ultimate load carrying capacity, for example. Then how we are going to actually convert it to the strength that we want to determine. So apparently we are going to follow up calculation, and then eventually we are going to generate a report, okay, for that. So this is the experiment on the left-hand side. On the right-hand side, it is actually the rebound hammer test. So this is a very widely used non-destructive test method to determine the strength of concrete. But I'd say it is not actually the actual compressive strength. It is, however, the hardness, okay, of the surface of the concrete. But the hardness of the concrete is related to the strength of the concrete. So there is a way that we can actually convert the value that we determined based on this rebound hammer. We convert it to the strength of the concrete. Okay, this is a very good estimation of the strength of the concrete. So for example, to do the the actual concrete test, we have to have the actual concrete sample, right? However, if we want to do some in situ testing on some, for example, existing structure. So apparently one way is that you can try to call the specimen from the existing structure or infrastructure, and then you can bring it back to the lab and to do the test. But that would actually apparently cause certain kind of defect to the structure. So in order not to disturb the structure, so a good practice is to, okay, for example, to use such kind of non-destructive test to do the testing. Okay, so these are just the 2 examples that our students can access to this virtual lab, okay, to do certain types of experiment. Of course, we have a whole range of different tests available. For example, even for the fresh properties of concrete, okay, for other like tensile tests and so on. So there are actually a lot of different experiments that the students can play with and can learn from. This page actually illustrates how our remote lab or how the virtual labs on remote lab runs. Sorry, this blocks my window. Well, so remote, we have actually quite a few remote labs at EIT. They are basically some workstations located on at different campus across the world. And for example, we have workstations based in our Perth campus, South African campus, and the UK office, and so on. And this actually provides the opportunity for students to access those remote lab at any time that you would like to. So you can actually book a session in advance to schedule the session what time you want to access particular remote lab. So each remote lab have been actually installed with different types of softwares or such kind of virtual labs, those kinds of virtual equipment and so on. So you can book the session and access that remote lab at the time that you booked for, and play with all the softwares and the virtual lab facilities over there at your own time. But of course, there is certain limitation that you have to actually have a computer, okay, and you have to have the internet access, right? So these are actually, I think, I do think it's a very, very effective way for our students to learn, and this experience is, I'm not saying unique, but it's very, very beneficial. Okay, at other universities or other providers, you may not find such kind of facilities, okay, or chances. So this page talks about different ways to access practical activities. So of course, the first one is the standard experiments we also have, okay, like what I showed in earlier, that we actually urge the students to go to the lab, okay, to do the experimental themselves, and also, okay, at EIT, we also have the we also actually kind of actually combined the traditional experiment with modern technologies. So we can actually, for example, okay, recorded certain types of experiment, okay, using videos, and then we can actually prepare the video by adding some created into a module, and then adding some like quiz questions and so on. So this is another way to combine the traditional experiment and convert it to some recorded interactive experiments. And the last one is actually the provide remote access to traditional experiment. Well, I'd say, okay, this method is currently at this stage is relatively more challenging for civil engineering equipment, because most of our equipment, we need to have someone to operate it. Okay, for example, imagine if you want to mix concrete, okay, you have to have someone to be there and to pour in those ingredients. But we are actually working out, we are trying to actually implement or develop such kind of remotely accessed experiment, so that at a certain stage, okay, the students actually can try to operate certain equipment, okay, from their end, from their computer remotely, and they can actually conduct the experiment remotely. But of course, it would be actually for certain types of, not for all types, for certain types of experimental work. And I'd say it might be more easily done for experiment in other streams. Okay, for example, for electrical or industrial automation, that might be easier. But for civil engineering, we are also developing such kind of activities, okay, for our students. Okay, hopefully it will be here very soon. So yeah, here I want to actually show you one of the recorded in interactive experiments. So this is actually exactly the second one that we listed here. So for example, we did actually create H5P module, okay, for this stress and strain experiment. Okay, so this is actually a tensile test, okay, on some metal strips. So as you can see that this H5P is actually a function that we can actually embed it into our learning management system. For example, currently the learning management system that we are using at EIT is called Moodle. So we can actually embed this H5P into this module, okay, into our Moodle, into our learning management system. So this is it can actually stand as a module itself, but you can see that yeah, this font is very small for me. So you can see that we actually can embed the theory. Okay, so the theory. So there is actually a video, okay, teaching students, okay, what is the theory? Okay, why do we need to do such kind of tensile test? Okay, what is the theory behind? Okay, and also we have videos, okay, for testing different materials. Okay, and also you can see that there is a chance for us to add some quiz. Okay, so the students actually can access this module, okay, at any time they would like to, wherever whenever they want, okay, wherever they are, and they can actually try to complete the associate assessment. Okay, and we have there is a chance that this can be get graded. Okay, it might be a part of the assessment, okay, in the unit that you are taking. I believe here we have another short video illustrating exactly the stress strain analysis interactive exercise using this H5P. Let me see if I can play it. Oh, sorry, bear with me. So I believe this is the interface that they're going to contribute. It's operating the machine. Turn on the machine, turn on. Measures. Yeah, so we see the curves on the screen. The resulting curve, stress and strain curve, which is the results that we are looking for from the tests. So basically, this kind of test would generate the results such as stress and strain history. Then we can apparently analyze the results and hopefully prepare a proper lab report, okay, for example, for such kind of activities. Yeah, it breaks. Yes, so this is just one of the examples that we have for the recorded interactive experiments. So I hope these are interesting to all of you. Yeah, I think that's all from me, and I hand it over back to Anna.
Thank you very much, Dr. Shasha Wang. I will take control now. And yeah, the main point now is to just summarize the main points we discussed today. As you can see at EIT, we have been investing a lot in terms of new technology. So engineering is quite challenging course to teach, but over the last years, we have been demonstrating our expertise and our knowledge when we can, honestly, we can engage students online and on campus in the similar way. We normally give similar opportunities to our online students and our on-campus students. So engineering is totally dependent on we need to keep our students up to date. We need to receive industry inputs. It's what we normally do at EIT. We receive industry inputs in terms of the cutting edge software that our students need to get prepared to find a job when you complete our course. Software, hands-on opportunities, you give you all the skills and knowledge needed according to the current industry demand. So that's why at EIT we offer the blended learning system. We have our pre-recorded lectures, but at the same way, every week you need to meet your lectures during the tutorials. We have online tutorials. This is our live sessions when you establish contact with your lecturer and with your colleagues. If you are studying online or if you are studying on campus, you're going to have similar opportunities, no doubt. And yeah, this is the keyword. In fact, when we ask students feedback about the perception, the students' perception about the course, about the units they completed at EIT, the keyword is opportunity. This is our main goal at EIT, give opportunity to students in Australia and overseas. So yeah, it's how we truly believe we can contribute to the qualification of engineers around the globe, not only in Australia. So yeah, I really like this word map because you can see opportunity is an indication that the students are looking for this type of flexibility. Students are working and some of them also need to balance work and study in order to get a better job. And others coming from high school, finishing high school, they want to continue their qualifications. And we offer opportunities from advanced diploma course until you can maybe join the doctorate program. We have a variety of pathways at EIT. So I think it's pretty much what we prepared to share with our audience. Now it's over to you, Barry.
Okay, thanks very much, team, and thanks very much to our audience. And as I've mentioned in the beginning, that I'll be sharing the QR code or the link that you need to follow in order to access your or to claim your certificate of attendance. So if you can just ensure that you quickly scan the QR code, or you can just follow this link. I'll paste it in the chat box just now, just a sec. Okay. Okay, I'm just going to post the link. And then I'm not sure if there's any questions. I see there's one that you wanted to know, where do the practical workshop happen? So yeah, so maybe also Anna or one of my colleagues can elaborate further on this. But obviously, when you are studying online with us, we've got a very unique method in terms of delivering practical learning. So that include we have workshops. There will be remote and virtual labs that you need to go through in order to do your practicals, and then obviously together with some simulations. So once you are registered EIT or enrolled EIT student, you have a student portal where you are able to access everything that has to do with your learning material. I'm not sure if Dr. Anna, you wanted to jump in to elaborate further.
Yeah, thank you, Barry. Yeah, at EIT, our master's students depends on the completion of a bachelor's degree. The workshops are compulsory, and we also have a compulsory workshop for the master students as well. So, but it depends where you completed your bachelor's degree. If under the Sydney Accord or the Washington Accord, we needed to have a look at this. But definitely you can join our workshops. We have workshops here in Australia and also in South Africa. Depends on what you need to complete based on your bachelor's degree. Yeah, I think this is the points we can clarify. We have other question.
There's one from Nomsa. Can I do masters with N6 civil engineering? So maybe just to clarify this, so with our master's programs, entry criteria, you need to have a bachelor's degree. And yes, once you've got that, then obviously you have to apply, and then it goes through to our admissions. They have to look at your qualifications. But yeah, entry criteria for a master's program is Bachelor of Science. I'm not sure if there's anything you wanted to add there, Dr. Anna.
Let me open my mic. Yeah, Barry, I think this is the most important part. I think the most accurate way to answer this question is just to share our entry requirements, because depends on admissions how they can get better information about the qualification you have and in relation to the entry requirements here. That's why I just shared the entry requirements of civil structural, but it sometimes it can be case by case as well. But definitely this is the question for the admissions team to get you better clarification. And it's the same entry requirements online and on campus mode. There is no difference.
And then there's another one for the need requirements for student joining for PhD. Is a published paper, is published paper necessary? So I'm trying to get that. Yeah, it says, is published papers necessary, and are the scholarship for PhD for students?
Yes, Barry. Yeah, I've answered on the chat. The publications are not critical. It's not a requirement. The published papers. I posted the link for you to check the entry requirements. You must have the bachelor master degree at least, plus some engineering experience. The scholarship, some partial scholarship available. You will find the conditions also at the same link.
It's a campus and lab in South Africa. So I'm based in the South African office. We're not a campus, we're just a support center for our online students. Anyone before we go? Okay, as I've mentioned in the beginning that we've got the whole sessions lined up for the whole week. So I'm just going to share another link. You can just go and have a look as to what you want to learn more from EIT. We've got this until this Friday, so just go and look at the subject that you might be interested in and register, and we're looking forward to see you online. Um, from my end, I'm not sure if my team, did you want to add any comment? Smart. I'm just going to share courses under our electrical engineering, so you can have a look and then let us know which one you are interested in. All right, on that note, I just want to say thanks very much to my team, Dr. Anna, Kumari, Igor, Shasha. Thanks very much for your support on this one, and I hope our people learned a lot from you. And then once again to our audience, I just want to say thank you so much for joining us this morning, and until we see you again on the next one.
Thank you very much, everyone.
Thank you, Barry. Thank you, everyone, for joining this session. Wishing you all the best. Take care.
Thank you.
Thanks. Cheers.